Yes, student, you have to watch this video. It is very important, one of the content which is utilized to explain many of the properties of compound. Isn't it? This is what? Lattice enthalpy. Lattice, that is what? Crystal lattice. The overall term is actually crystal lattice. So, enthalpy means energy. Energy releases when opposite ions means a plus and what? Minus. Plus and minus come close and neutralize each other forming a crystal lattice okay, called lattice enthalpy. As greater the lattice enthalpy, more will be stability of ionic compound. That is, simply you can say the lattice enthalpy is directly proportional to stability. So, if we compare the lattice enthalpy of different type of ionic compound, then we can compare their stability magnitude. Therefore, it is very important. But how to calculate the lattice enthalpy or how to compare the lattice enthalpy? So, very first we should have to know how to find lattice enthalpy and what are the factors which affects the lattice enthalpy. So, again, this topic is very important. Factors affecting lattice enthalpy. So, the first one is similar charge magnitude. If opposite ions are of similar charges, that is similar magnitude of charge, then more will be lattice enthalpy. Like what? If plus 1 and what? Minus 1, or you can call plus 2 is neutralized by minus 2, then the more will be lattice enthalpy. Okay, next one, charge magnitude. Okay, as greater the charge, more will be lattice enthalpy. Like here, you can call NaCl what? Plus 1 and minus 1, isn't it? But if we say Mg and O, so Mg 2 charge, this is minus 2 charge. So what? The lattice enthalpy of MgO will be higher as compared to NaCl, because in NaCl the charge magnitude is 1 and 1, but here what? Plus 2 and what? Minus 2. That means its lattice enthalpy will be higher. Okay. Third one, similarity in size. Okay. If opposite ions have what? Similar size, then more will be lattice enthalpy. More will be what? Lattice enthalpy. Like, the better thing of what? Take the example. Now the similar size, like Na cation size is similar to size of Cl anion, isn't it? But if we discuss next one, like Na and what? I. Now the size of Na and I are very different from each other. Why? It is because I, okay, belongs to very down the group, therefore its size is bigger, while the sodium belongs to third period only, therefore there is large differences in the size, so the lattice enthalpy will be lesser. And here what? Similar size, therefore lattice enthalpy is the higher. Are you getting? If the size are dissimilar, the lattice enthalpy will be lesser. So student, you have to keep in mind all these three factors of lattice enthalpy, which will be helpful to explain the solubility and the stability, that is the thermal stability. I will discuss few questions regarding it, like why NaCl is more stable as compared to NaI. So what we can say? We can say the lattice enthalpy of NaCl is higher due to similar magnitude of charges are present, one thing, and second thing, what? Their size are similar, while in the case of NaI the size are dissimilar. But now the problem is, how do you find the size are similar or dissimilar? So again we have to go in 9th class. What? You have to learn atomic number, you have to learn the position of elements. If you know the position of element, along with what? Periodicity in the size, like along a period size decreases, but down the group size increases. So the sodium is quite big inside, that is sodium and chlorine belongs to same period. So size of Cl should be smaller and size of Na should be bigger. But one thing is there, what? Na is not neutral here, it becomes Na cation. Size of Na is bigger, but Na cation is smaller. Similarly, size of Cl atom is smaller, but if one more electron is added to it, now its size will expand. That is, its size will become bigger. So the smaller becomes smaller and smaller becomes bigger. Therefore, their size are similar.